let's go over your chapter 18 review. I don't want to, drill it in because you can see what's written there and you see stuff, but you see the answers and such. But I want to go over some key things that I saw that were wrong on the review. I'm sorry, on the quiz that I handed back to you. Okay, I want to do that too as we go along. And really point out the difference again between a question about the population. Okay, so everybody keep straight in your head questions about that population versus questions about sampling distribution. Okay, and I'm going to stress that again and give you indications as how you know which one it's asking a question about. Because I guarantee you on the test, in the free response, there's a time where it will take you through asking a question about the population and then asking a question about the sampling distribution. Okay, so you got to know the difference. All right, so here on this first one, it's talking about the age of college students, okay? And here's the deal. I knew that this problem was talking about sampling distribution because so what's the probability that an average of however many students, 19 or whatever, how many students was it, 36 students, is less than 25 years old. So that told me I'm wanting to know this right here. Do you see this notation, how it has X with a bar on it? So I'm asking if the mean of a sample is less than 25, okay? And so when that happens, then I take the standard deviation and I have to divide it by the square root of n, okay? But if this question had said, what's the probability that a college student is less than 25 years old, they would have needed to have told you that it was normally distributed, okay? Because you have to know, they would have had to have told you that. But this is how you would notate it. The probability that a student is less than 25 years old is just a plain X. And on that one, you would use the population information they gave you. They gave you that the mean is 26, and here, the standard deviation of the population is 4 years. Okay? But because this problem asks about sampling distribution, you used the standard deviation of 2/3, which of course is smaller because the sampling distribution standard deviations are smaller. Okay. All right, questions on that? Don't forget to do your conditions. All right. Okay, this next one, some people were a little concerned. First of all, it had a sample that it is a mean problem. And so remember that on mean problems, large enough has to have a sample that is greater than or equal to 30. And here's the proportion large enough. And in this case, it didn't have a sample that was large enough. They were sample size 19. So how was I still able to know that I could use the normal model? Because the population, they said that the parent population was normally distributed, okay, for wherever that went. I don't know. Oh, right here. So they said that the population is normally distributed. So anything that drops out of it is good to go. All right. Now, one quick thought. If you got a sample, so see it said a sample, what's the probability that the sample has more than 19? Then I knew I was using this different standard deviation here, not the standard deviation of the population. Okay, so we weren't using that one because it asked about a sample. But if you had gotten one that was 8 standard deviations out, so if you had really gotten this and the teacher was claiming that it takes students an average of 75 minutes to do this test, what would you say to that teacher? Yes, very good. You'd say very respectfully, you are wrong. No, that's right. Finger snaps and everything. Okay, so you would say that you think that what the teacher is claiming is wrong because you got a standard deviation, you got a sample so far out there that that was unrealistic to have gotten if 75 is really where the data is centered. Okay? All right. Next. Okay, so on this one's a good one to talk to you about. What do you do if the conditions are not met? Because this problem states up top that this 500 fuses, and it explicitly notates that that is the population. A lot of times you don't have them like being that definitive and making sure you know that is the size of the population. But they did that because they wanted to see you, talk about the independent condition not being met. Because a sample size of 100 is not less than 10% of 500. So, so that's a violation of the independent. Okay? So I wrote that. Yikes, I don't think the normal model really applies because this independent condition is not met. But then I continued just to cover my honey. And so I said, but if it was normal, and then I did the problem. Okay? Always a good idea. All right. I think I might have shown you guys this yesterday or talked to you about it. Again, I'm kind of, looking to see that you are notating things, writing the letters down correctly, that you're writing the letters down correctly in your, you're just kind of like warm and cozy and quiet and just kind of, okay? I know. But I'm kind of looking when I see, when I graded your quizzes that you notated them right. And so I would try to fix them and try to put in the little subscripts, okay? It will help you keep it straight if you write the parent population one just like this, and the sampling distribution one like this, okay? Or if it's of a proportion like this, okay? That could help kind of keep your brain straight as to if it's parent or sampling distribution, okay? So do keep that in mind. And that the sampling distribution ones are smaller. Sampling distribution ones are smaller because you're dividing by the square root of n. Okay, 5 was pretty much a straightforward problem, not really going much over that one. And so 6 is also a pretty straightforward problem. I wanted to just reiterate to you that you knew you had to do sampling distribution because it asks, what's the probability that a mean is in between these two numbers? So do you see how I wrote this here? What's the probability that in X bar, not just one item, but that a whole sample average of items is between 935 and 960. Okay? This problem is not asking what's the probability that one item, is between 935 and 960. If it was asking you this, what standard deviation would you use? The original population standard deviation. If it asks you about a mean in between these two things, what standard deviation do you use? The one that has been divided by the square root of n, the sampling distribution one. Okay. All right, so that's what I did up here. See, my sampling distribution is 130. Standard deviation 130 divided by square root of 42. So I found two z-scores. I norm CDF between those two z-scores. Okay? And I did my conditions and everything. All right. So number 7 is the first proportion problem on this review. And I want to stop a moment to remind you of what was happening on the quiz in some cases yesterday. I wanted to reiterate to you, do not mix up your units. Okay? All proportions, proportion, 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 standard deviation. Keep them all proportions, not like a number of items and a proportion. So keep them all proportions. All right. Keep in mind that large enough is the proportion large enough. Since this is the first one, see here, at least 10 successes and at least 10 failures. Okay, now I boo-booed on your key. And I don't even know how many years. I think probably 2 years I've had that same answer key I've used, and I've not ever seen. Man, first period, I just happened to glance and notice that I did my large enough wrong. This is a proportion problem, and look at the large enough I had done. I said, oh, 70 is greater than or equal to 30. Woohoo! What's wrong with that? That's the mean large enough. So, my bad. Okay, so should not have used that version of large enough. Instead, it should have been n times the p and n times the 1 minus p, which are both greater than or equal to 10. Okay? All right. My first period's usually pretty good at catching those mistakes, and they didn't catch that this morning. I thought they probably could have. All right. Now, let's talk about number 9. Because I've pretty much drilled into you, hey, anytime you use a z-score, you need to make sure your conditions are met. Well, and then I didn't write them out here. So that's another, what the heck am I thinking? I don't know. So here we go. What I'm going to do is say, and so I've kind of thought about this. I mean, it is important that you still note that I knew it was a parent population question because it asked about just the probability of finding one student. So the probability of finding one student means that I should use this parent population mean and standard deviation, okay? And as far as conditions go, I mean, there are some that have to still be met. So I really should have written, and I did, sort of. You do need to make sure that random is covered. You need to make sure that the, whatever it was, is it a person? Okay, student, randomly chosen. That's important. So the random, okay? You also should emphasize to the grader that you know it is normally distributed, because that's important. You can't do z-score stuff unless you know it's normal. And the thing is that it is stated approximately normal. Underlining this in the paragraph is not enough emphasis to the AP grader for them to say, oh yeah, they know it's normal. You need to write that the population, is approximately normal, or whatever it is that it said. It's kind of like when we conclude our conditions and say the normal model applies. So this has to be written, and I think it's good practice to do the random. On the independent one, I'm like, I don't really think that's necessary, because what are you saying? 1 is less than 10% of all students? I guess. I don't know what it matters. But anyway, but random and the fact that it's normal are essential still. Okay? All right. Now, oh, you know what? I'm curious to see how you did on this number 10, because this is an actual AP free response question. Okay, so some people asked me, they didn't know what it was talking about. They were like, what are you supposed to do on this problem? And so it really is just doing a full problem, and it's just spread out between letters A, B, C, and then it adds a little twist to it on part D. Oh no, sorry, parts A and B are normal, and then it puts a little twist in part C. But this is exactly how a real AP free response read. So the conditions for shape are your random, your independent, and your large enough, because then you know that the sampling distribution is normal. The parameters are these things, your mean and your standard deviation. So I had actually written those in part B. I hope that they would have given credit for me, even though I wrote them down in part B. Okay. And then part B, straightforward. What's the probability? It's less than 2, z-score, and find your probability. Okay, part C is where they kind of, want you to take it to the next level and do the problem in terms of year, because originally, as stated, it's in terms of a week. So it's somewhat known that there are 52 weeks in a year, so I just multiplied my numbers by 52 so that I could get them in terms of a year. But you could have likewise divided 100 by 52 and done it that way. So you either get them all in terms of a year by multiplying by 52, or you back it off and do it all and turn this 100 into a week, and they would be the same. Okay? Questions on that page? All right. Here's where review comes in. Okay? But I'm telling you that every time I pull back something that we've done in the past, then this is like brain research stuff, that little electrical pathway where you go from thinking to like retrieving the information about how to do a binomial thing, that gets stronger, that little electrical highway. So if you thought about this problem, you just strengthen your ability to kind of go, oh yeah, that was a binomial problem, and like how to do it. So good for you. So let's take a look. I hope that it kind of like rung a bell when it talks about you do it 10 times, you know, flip this coin 10 times and find probability exactly 8. It lands on that thing. On your formula chart, that is here where we said, okay, so we're having probability that you have exactly 8 successes is what we're having. And this n is 10, and this k is 8, and then your probability of success is a half, and so on. So that's going to take care of having those 8 coins sprinkled anywhere amongst those 10 spots. Okay? Otherwise, you'd have to like do all the different combinations. All right. So the way we've done that in the past, look at here is how you showed the work. Probability that x equals 8. Do not have a fraction line there. I still saw some fraction lines, and hopefully I didn't have that in my key. There's no fraction line here. It's 10 choose 8. It's not a fraction. And then a half, and I want 8 of those that are heads, and probability of tails, and 2 of those. Binomial PDF of n, so the number of trials, the probability of success, and the number of successes. Trials, probability of success, successes. Okay, and so then here you get your answer, which you had to use in part B. And so if you want to know how many times out of 100 you expect success, you just multiply n times p 100 times this probability from part A. Okay, now here's a little AP strategy session, just like a little bitty hint. If you don't know how to do part A, but you think you might know how to do part B in a problem, okay? You can make up an answer that's plausible or reasonable in part A. You know, show no work, just put n equals 5% or whatever it is you want to put. If you use the incorrect number that you wrote up here, if you got it wrong, but you use it correctly in part B, you get full credit for part B. Because you are showing that you understand part B and you understand the process, you just are using a wrong answer from part A. You will get A marked wrong, but B is full credit. Okay? Okay. All right. All right, going on to this, I want to show you that this is also review and that I kind of have a debate on part E and then the one on the next page. I kind of think the way it was worded was a little ambiguous. When you say you want both of them to be black, I guess that means you want 2 different people. You want both, you know, like one person and then another person to be black. So if that's the case, then you're really not replacing that person. And so this is the way it should have looked, where you took out the person and had now 88 out of 402. And that's not what I have written there on your review, but I think this, you know, in hindsight, I think this is probably more correct. Yes, ma'am. Probably not. Because if I gave you a review question from that stuff, it would be pretty basic. Okay? All right. This one also, part F, Again, I think this is probably more valid because neither one of them being a vegetarian, you want that one and that one to not be a vegetarian. I don't think you put the person back in the bag. But either one, it's a little ambiguous. I think if it was a real AP question, hopefully they would have worded it more clearly. Okay, part H. This is that thing about independent. I actually want to have a little bit more work room here, because the way I taught y'all, remember this, and I just picked a race. You could pick any race, black, white, Hispanic, whatever, that they have data on. I picked Asian, okay? You could also put vegetarian or not vegetarian right there, okay? Doesn't matter. Pick either a race or a diet. Then do that same race or diet given that something else has happened. Okay, remember this? So basically, here I'm saying, given that you're a vegetarian, at what rate are you Asian? Is it the same rate as Asians overall? Okay. And so when I had gotten my numbers overall, there's 13.9% Asians. But when I did this problem and I just looked at the vegetarians, that are 100 of them, 21 of which are Asian vegetarians, that was 21%. So, wow, given that you are a vegetarian has had an impact on the likelihood, the probability of you being an Asian. Therefore, what does that mean? Are they independent or not independent? They're not independent, okay? So the way I would word that, it would say, and it's nice to just start with, the way that this is notated. Given that you kind of start your statement right here. Given that you are a vegetarian, and then what does it do? What is, given the fact that you're a vegetarian, doing to the probability of you being Asian? Okay, good. Given that you are a vegetarian, you are Asian at a higher rate. Or it increases the likelihood, whatever, however you word that. Okay, so so they were not independent. Okay, one last thing. It was a good question that I had earlier today. In order to disprove, or in order to show that diet and race are not independent, if you just find one of them that's messed up, then you can say all of diet and all of race are not independent. But what if this one had shown okay? And this is really annoying, but I'd have to go check the black vegetarians, the white vegetarians, the Hispanic vegetarians, and all of them, and see that all of them, in order to make a claim that diet and race are not, the whole generic diet and race are not being affected. Okay, that's it. That's your review. Any other questions? Okay,